right? We calculate the accounting profit, we just do the accounting profit. Okay? If you want to calculate the economic profit, you have to include all our profit costs and all the opportunity costs. So we have an example like besides like wage, resources, rent, insurance, material. We have to also include the time of the manager for running a business at the opportunity cost. That's good. So what is the difference between short run and long run? Please.
So short run is for what you can see immediately, and the long run is like what you is when you think about the future and what and prepare for the so let's say you're in a factory and it might cost a lot of money right now, but in the long run it will generate a lot more. So that's the difference.
Yeah.
If you just think about the short term, then you'll see that it takes a lot of capital, and sometimes people will not do it.
Yeah. And now, wow, what is the difference between short run and long run? In the context that we learned about producer choice. In production, what is the difference between short run and long run context? We
I think that's in some product we can fix the inputs by how many employees we will hire and how many equip. But we cannot expand the business.
Yeah.
But in the long run we can expand it and maybe we can change all the inputs.
So how long is short run and how long is long run? How long is short run and how long is long run? Phượng, how long is short run?
The short run is a time period during which some inputs are fixed.
But how long?
I think those factors in the
Yeah. So remember that actually we don't have a specific time period for short run or long run. We don't have like 3 years means short run or 5 years means long run. We don't have that kind of time period. So short run or long run period in economics is just an assumption. Okay, we assume that in the short run, some kind of input like machine, factory, or kind of equipment are fixed in the short run. While other kind of input, we call that variable input, that incur variable costs like labor, material, are flexible in the short run. Okay, so that's the main difference between the short run and long run. In the long run, everything is flexible. Everything can be changed in the long run. Even the equipment, machine, factory can be changed. You can expand the factory, you can buy more machine, buy more equipment. In the long run, not the short run. So that's one of the assumptions that we need to identify something for the marginal product, something so on. Okay, that's good. So today actually we will learn more about ice quant and ice cost life. So what is the law of premixing marginal return? Ngọc, what is the law of premixing marginal return? So first, let's talk about marginal product. What is the marginal product?
marginal product is additional products every year also.
So marginal product is the additional product that can be created when we hire more variable input. Let's say let's say in the short run, if we include the number of workers that we hire, we can create more output. That's a marginal product. Additional product created by additional variable input. Okay, so that's a marginal product. An average product, we take the total output minus over the total input. Okay, number unit of input. So talking about marginal product, we talk about the marginal productivity of additional variable input. Let's say additional worker. Agree like how much output an additional worker create. Okay, that's the marginal product. And the marginal product face something we call the law of diminishing marginal return. Okay, because the marginal productivity of additional worker decrease. Okay, so why? What is the intuition? Okay. Why normally in reality we observe law of diminishing marginal return?
Because in reality, we can enrich our laborers about our technology, about our lands. It is limited, and that means that when you reach to the point that when you enrich the labor, your royalty cannot be enriched.
Yeah. Yeah, so basically, because in the short run, there are some variable input and there are some fixed input. It's kind of. So let's say the number of machine, land, a factory are fixed in the short run. And then we hire more and more workers. So basically the productivity decrease to crowded, right? And the machine, the factory is overused. That's why the marginal productivity decrease. And we have I think we have an example like a small coffee shop, right? So we have the kitchen is limited in the shop run. The number of coffee machine is limited in the shop run. So when you hire more and more worker, the number of cup of coffee that kind of worker can decrease over time. Because the kitchen too overcrowded. Okay, so we call that the law of diminishing marginal return or law of diminishing marginal product. So that's good. More of you. So you give more of key concept from the previous lecture. So what is the firm objective? Somebody can tell me one of the main assumptions. So don't look at the lecture slide. Just remember what is a firm objective. One of the main assumptions in economics. What is a firm objective? You can type the answer into the Mentimeter. To work in a wage which maximizes their profit. So what is the firm objective? This is very important assumption that we need for upcoming topic. Anything else? Anything else that you want to share with us, Ying An? Yeah. So basically, we may have some other assumptions in the upcoming lecture, but basically, till now, the main objective, we make an assumption that the main objective of firm is to maximize their profit. Okay. So what is the main objective of a consumer? So now you can when you think about any principle that we apply to a firms or producer, you can relate it to what we learn with consumer. So what is the main assumption about the objective of a consumer? What is the main objective of a consumer? So what make it happy? Consumption, but we have limited income. So we assume that. So in previous topic. So basically, we try to identify the tendency where the consumer they can maximize their utility even their limited income. So now we apply that kind of parallel assumption to producer. We try to maximize the profit of a firm given their limited input, limited resources. Okay, we assume that the consumer try to maximize their utility given their limited income. Now we make an assumption that firm try to maximize their profit. And profit is a difference between total revenue and total cost. Okay, so this quick lecture, so basically we mostly focus on this side. So if you want to maximize the difference between the total revenue and total cost, you have to try to maximize, minimize the total cost, or you have to maximize your revenue. Okay, so this one is more complicated because it depends on the market power or something like that. We will talk later, so don't worry. Now, today we focus on this one. Try to minimize the cost of a firm. Okay, if we want to maximize the profit. Okay, that's good. Somebody can give me some example of opportunity cost to be included in this cost. An example. Any other example? If you want to talking about economic profit, so any other opportunity cost should be included in economic cost beside our profit cost. Some example. An example. So imagine if you want to run your own business, right? You want to start up, you want to run your business, just a flower shop, coffee shop. What are, besides the money that you have, the cost that you have to pay every month, like wages for the worker, rental, something like that, material. You have to buy flower from Dalat and then sell, package it and sell it in your flower shop. So any other opportunity costs that we should include in your business, in your project. Anything else? So you are now an economics. Things like economic firm have to consider resources. You can limited resources, of course. But I think that's enough for the review. So you can think about the time, your time to run this business, right? Or let's say that coffee shop is operated in your house. Actually, you can rent that kind of house and earn some money, right? Or let's say you have some savings. Instead of using that saving to operate shop, you can deposit in your bank to earn some interest rates. So all of them are opportunity costs of running this business. Okay, so economics make decision based on economic profit. Okay, so sometimes we may have positive accounting profit, but a negative economic profit. But we make decision based on economic profit. Okay. Yeah, choose the best option for you. Yeah, so we have some example of variable costs here, labor, material, something like that. For fixed costs, what do you have? Machine, land, factory, like that. Capital, like that. Okay. So now let's go back to the lecture. What we already covered. So what is the production function? So we have, for consumer, we have utility function. So last week we have a tutorial on utility function. So now we have a production function. Okay, so production function are basically show us the relationship between the input and output. Okay, so how much you pay for the input and how much that kind of input can bring to the output. Okay, so relationship between, and also a good production function should represent something we call a limited marginal product. Okay, so if you remember the utility function that we did on Wednesday, we use a sweater. And now we also use a sweater. We want to represent the limited marginal product. Okay, so let's say you use more capital or more labor, you can create more output, but with a limited marginal rate. We use sweater here. Okay, and also it shows the complementarity, the collaboration between labor and capital. Now let's talk about. Okay, so please review. We have many concepts now, but hopefully you can systemize them, organize the concept. If you understand it, it's not hard to remember, but if we just try to remember without understanding, it's very hard to keep the concept. So now, okay, so because of the law of diminishing marginal product, so let's say if I represent a production function here, x1, I got a total output, right? So in the short run, so for the production function, so in the first part of topic 3 on Wednesday, we assume that in the short run we only have a one variable input, and that's a labor. Okay, we assume that there only one variable of input. That's the labor. So you hire more labor for your more worker for your coffee shop. You can create more on one sandwiches shop. You can create more sandwiches. Okay. So if I put the total output on the y-axis and the number of worker here, okay, labor here. So what is the shape of the total product? It should be like this, or it should be like this, or it should be like this. A or B, C. Sorry, say B here, or C. So what is the shape of the production function? It should be A, B, or C. That A or B or C. Why?
Because if you have one level, if you have more level, your total products will increase. If you have a lot of, so like the utility, so the product is not increasing more.
Yeah, so we hire more and more worker, the total output increase with a diminishing marginal rate, a diminishing rate, right? That's why this curve 8 represents the production function, and it represents the diminishing marginal product. Okay, it flattens out. Okay, so for this one, what is the problem of this one?
It's constant.
We have a constant marginal product. So when you double, let's say you double the input, is exactly double the output. Okay, this one, when you double the input, it's more than double the output. You double the input, it's more than double the output. This one is very rare. It's not common in reality. Sometimes not common. Let's say you hire more and more worker, it increase the productivity significantly because of specialization. Do you find like the builder? So each builder actually have they specialize different kind of tasks when they build a house. So if you have a good team, that increase the productivity significantly, but not common. So it is the general state of the production function. When we have a one variable input, okay, keep that in mind. This one, okay, flatten, slow decrease. When you hide more and more. Yeah. Okay, so we have an increase in marginal product. Not common in reality. It's one constant marginal product. Very unusual in the short run. Now let's move on with the second part of the lecture this week. We talk about how to minimize total cost. So today, we assume that a firm, objective of a firm is try to maximize their profit. So if you want to increase your profit, economic profit, you have to find an optimal choice to minimize the total cost. Okay, so ISO brick work. ISO equal to ECON. Okay, ISO each mean ECON. So the first one we talk about the ISO first. ISO mean ECON. So we have quant means quantity. Okay, so ISO quant means equal quantity. So now we expand what we learned on Wednesday. Now we include two variable factors of production, two variable input. So on Wednesday, because we just start by representing the demixing marginal product, we only include one variable input. That's the labor. Okay. So today we will assume that we have two variable inputs. So basically, talking about ISO equal quantity, we talking about what is the combination of the input and that produce a desired level of output and a lower cost. And then you can choose the optimal choice for firm. Optimal combination of the factor of production depend on two things: the the productivity of the inputs and the cost of each factor. So you can relate it to what we learned in consumer choice. So we choose the optimal choice for the consumer depend on the individual preference and the price of the goods that they consume. Okay, so very similar logic here. So now because we have two inputs, let's say K for capital and L for labor. So talking about consumer choice, we assume that in our model for consumer choice, the people only spend their money on two goods, right? Do you remember X and Y, movie and food, like that. So now we have two variable inputs. When we say something variable, it means flexible. It can be changed. Okay. So we have two inputs for production that can be changed in the short run. K for capital and L for labor. So in this example, we have a small business, a small factory that basically they produce diapers, diaper. So for baby. So basically, we have 5 different possible combinations of the units of input to produce 100 diapers. So we have let's say we have 5 combinations of capital labor to produce the same level of output. Okay, so this one we have 2 units of capital. Let's say I put capital on the y-axis, and L for labor, and K for capital. So the answer one like this. Okay, this one we use a lot of capital here. So this one. So this one represent by A or B or C or D or E. A or E. E. This one represent E. Yeah, this one is good for to represent E. Okay. So we have 5 combinations, or you can say 5 technologies. Okay. So this kind of technologies, you can call this one is capital intensive. You have a lot of machines like that. A lot of capital here, or just say capital intensive. For the technology A or B, so you can call that the labor intensive technology because we need a lot of labor. Okay, so here be A, B around here, C, D. So we have a 5 combination of capital and labor, and that produce the same level of output. Okay, so along the isoquant, that's kind of firm produce the same level of output. Q equal to how much? How much of output?
100.
100. You can choose any combination between capital and labor A, B, C, D, E, and it produces the same level of output 100 diamonds. And we call that the isoquant. That's why isoquant means equal quantity of output. Okay, so isoquant means equal quantity of output. So that the meaning of isoquant can have different kind of combination between input to produce the same level of output. So what is the kind of curve in the consumer choice related with the concept of isoquant?
I see in different color.
Yeah, so what is the related curve from the consumer choice? Yeah, good. That's good. I see. Indifferent. So we have different kind of combination between consuming with A and B that give you the same level of satisfaction. Here, very similar. So we apply similar logic here. So the firm have different kind of combination between 2 inputs. Okay. That produce the same level of output. 100 diamonds. Okay. So now, can somebody So an isoquant is a curve showing all input combination. So we need to say một cái capital L that can produce a given outlet 100. So can somebody give me some property of isoquant based on what you understand about IC? What are the main property of isoquant? We. So can you please apply the logic that we learned in the consumer topic? So what are the property of the isoquant we can indicate based on what we understand about consumer?
In the same curve they produce the equal
Yeah.
quantity.
So first one, any void along a specific isoquant give from the same level of output. Okay, that's good. Second. Second.
It can flutter to the right.
And it will get flatter to the right.
Yeah, that would flatten out to the right. So let's say it's when you go downward to an isoquant, it's flattening out. Okay, because of
Law of diminishing marginal returns.
that's good. Because of the law of diminishing marginal return, that's why it flatten out to the right. So basically, let's say because an IC represents a trade-off between capital and labor. Okay, so moving from E, let's say moving from E to A, you reduce using capital and you have to hire more labor to maintain the same level of output. You give up the capital, you use less capital but you use more labor to maintain the same level of output. So the slope of the IC represents the trade-off between the rate to exchange capital and labor and maintain the same level of output. But the rate of substitution between capital and labor change along the isoquant. The rate to substitute capital for labor change along the isoquant because of the law of diminishing marginal product. Okay, so let's say from E to D, you can give up a lot of capital, but you don't need to hire much more labor to maintain the same level of output because the worker is very, very productive. Yeah. So the first, the second, the third worker is very, very productive. They can create a lot of output. Okay, to maintain the same level of output. But when you go moving downward, you have to give up. You cannot give up much more capital, and you have to hire more and more workers to maintain the same level of output because the worker is not productive anymore when you go downward. Okay, the law of diminishing marginal. Very good. Any property? Certainly, Phương. So we say the first property, any point on a specific isoquant given the same level of output, it flatten out to the right because of the law of diminishing marginal product. Any property that we can indicate for isoquant. Okay,
The higher curve, it means the higher quality we get.
that's good. So like what we learned with the consumer. I see. Higher isoquant represent higher quantity of output, and lower ICs. Lower isoquant represent lower quantity of output. Okay, that's good.
Presentation.
So we have, so it's kind of a scenario. So basically any combination between capital and labor give us a quantity of output of 50 units that represent by itself. Okay, this one is a 100% unit of output that we just represent, and here any combination between capital and labor give us higher level of output 150. Okay, so higher isocon mean higher quantity of output, but any point along each isocon represent the same level of output. Okay, good. And now let's time for us talking about something we call the marginal rate of technical substitution. Okay. So the marginal rate of technical substitution, very intuitively, very similar to what we learned with the marginal rate of substitution. We learned about IC, right? We did the rate that you substitute consuming good A and good B to make it the same level of power. You have a limited income. If, like, let's say you go less for food, for dinner, for restaurant. So normally a consumer, like, they need to go to more for movie, for music to maintain the level of happiness. Okay, so here very similar. We have something called marginal rate of technical substitution. Okay, actually this one, I think it's better to put an end. One more into that's fine, but I think this one is more appropriate because we are going downward of IC. So now talking about the slope of an isoquant. Okay, the slope of an isoquant. You told me that you don't like derivative, so I respect your preference. But anyway, when we're talking about the slope, remember that any type of curve, when we're talking about the slope, so the slope equal to delta, let's say the delta y in general term, delta y over the delta x. It is something we call the derivative of y given x, but you don't want derivative, so that's fine. So just remember when I talk about the slope of isoquant or slope of particular something like that, it always represented by delta y over delta x. And here, because we put k on the y-axis, so that would be delta k over delta l. Okay, the slope of the curve equal to the delta k over the delta l. Okay. And marginal rate of technical substitution is the rate at which a firm can substitute capital for labor and hold output constant. It means when you move downward, going from F to Z, you use less capital and more labor, but you hold the output constant. Okay, and that's the meaning of MRTS, the rate that you can substitute capital for labor. Okay, so when you move downward from F to G, so what is, so we have like minus delta K M B. Okay, what is it is the marginal product of capital. Okay, and this one must be equal to delta L, because you go from F to G, you use more labor anytime, and D L. So what does it mean? Somebody can tell me, Huy, what does it mean?
Difference in K and then
Just say something intuitively. The meaning. So don't get too much about mathematical here or technical formula here. So what does it mean? You use less capital. This is the marginal product of capital. Okay? So go moving from F to G, you use less capital by delta K. Okay? So this one represents the
decrease in capital.
the quantity, let's say the quantity of output firm that a firm produce less. Okay, because from use less capital. Okay. Okay. You understand it? So the quantity of outputs that a firm have to produce less, because now we use less capital, right? So you use less capital by net delta K, okay, and correspond to the marginal product of that kind of capital. The quantity of output that firm produce less because of use less capital. And remember that along an adjuvant means equal quantity of output. Okay, so along an adjuvant, we hold output constant. We are holding output constant along the adjuvant. Means when you give up some output because you use less K, you have to, so that kind of option would be compensated by the number of labor now you produce more output for you. Okay, so here I would say the quantity now I'm trying to like take more notes, but more for you if something that would be maybe useful for you. So quantity of output firm produce more cost firm use more. pretty effective, especially in the pandemic when we have to hold a lot of lecture online. So along an IC, the quantity of output you produce, a firm produce less because they use less capital equal to the output that a firm can produce more because now they use more labor. Okay, that's the meaning of the isoquant, the same level of quantity of output. Any combination FG, H, K, L, N, X, Y, Z, any point along an isoquant produce the same level of output. One of the reasons that I don't write out many notes before because blackboard is too small. So here, from here, you can arrange this equation, and you have minus delta A over delta L equal to M B L over M B K. Okay.
It's so easy.
So now we can come up with the slope of an isoquant equal to negative delta K over delta L equal to M B L over M B K, the marginal product of labor over the marginal product of capital. Okay, very similar logic that we learned with independent. And it is something we call the marginal rate. Marginal rate of technical substitution. You can trade, you can choose capital intensive technology, or you can choose labor intensive technology. You maintain the same level of output, and the rate that you extend capital to labor depend on something we call the marginal rate of technical substitution. Okay. So the slope normally represented by negative. Negative of now let's talk about the isoquant slide. So that's the isoquant. Isoquant represent isoquant represent the equal quantity of output for different kind of technology. Talking about an isoquant slide. So isoquant slides basically represent all combination that cost the same amount of money to the firm. Any kind of option along an isoquant cost the same amount of money. Isoquant. Isoquant slide is a straight line that represents all possible combinations of two inputs. Okay, basically now we are talking about labor and capital a firm can afford or given person. And along each as a cost line got the same. Okay. So can I clean the board? Actually, very easy to represent an as a cost line on the graph. So here, again, ISO means ECON, right? So ISO cost means ECON. So any point on each ISO cost represent the same cost of input for the firm. So now, if I put an ISO cost here, again, I put capital on the y-axis and have the labor on the x-axis. Okay. So in this example, we have the total, let's say the firm have a total budget, total cost that they can afford. In this example, $6, $6 million. And you have the price of labor equal to the price of K equal to 1. Okay, so how can I represent this kind of ISO cost line on the graph? That would be a straight line. Okay. So what is the intersection with the y-axis? What does it mean?
The money. See.
If you spend all of the budget on capital, how many units of capital that you can spend on? 6. Okay. Here, if you spend all of the budget, that's kind of firm, spend all of them its budget on hiring labor, and hire 6 labor. So here the as cost line. Okay. So mathematical. So if we have the price of, in general version, we have the price of labor times number of labor plus the price of capital times the number of capital equal to total cost. Right? The total cost that the firm can afford. Okay. So now, we can solve for gain. So normally we represent like y equal to a plus bx. Okay. So because we put k on the y-axis, so now we can solve for k by k would be equal to dc minus b L times E L over D. Okay. And now we have K equal to DC over BK minus BL over BK times L. So this is general version. And now with this one, if you have the total cost 6 and price of labor and capital equal to 1, so from this general version, and write K equal to TC over VK equal to total cost over the price of K equal to 6 minus PL over VK 1 times L. Okay, so it is K equal to 6. Okay, so 6E here. Here, so I put equation 1 here. From 1 in 1, T say TC total cost over the price of K, we call that intercept. Okay, the intersection between the isocost with I can put it for here. The intersection between isocost line and y axis. This one. Okay. And here we have minus BL over BK. You what? What is it? It is the intercept, and this one is what is it? Slope. Okay. Slope of the isocost. Very good. So the slope of an isocost represents something we call the relative price of K and L. The relative price. Okay. So this is one of the main difference between isocost and isocost. The slope of an isocost is constant over each specific isocost. It always equal to PL minus PL over K. So if the price of labor and capital do not change, so we have a constant slope. That's why it's a price line. So the slope here, let's say this point, the slope here, equal to the slope here. Equal to the slope. So easier to understand. A little bit similar compared to the isocost. Isocost, the slope change because of the law of mimicking isocost. Okay. And here, so one quick question. What happens if, let's say, the price of labor double? Let's say the price of labor. What happens if the price of labor is equal to 2 and the price of capital is still 1? What change? Just double check. What change with the isocost?
Rotate.
It shift or rotate?
It rotates to the left.
Rotate to the left.
Yeah.
On the x-axis or y-axis?
On the S.
On the x-axis because the price of labor increase. So now if you spend all of your money on the labor, you only can afford for 3 labor. So at that time, the relative price of capital and labor change. That's why the slope change. Okay. And then, so now another question: if I give the price of capital and labor holding price constant, and I change the total budget of the startup. They have more investment. Let's say they have more investment, and they can afford, let's say, the total cost like 9.
It's shift to the right.
It's shift
To the right.
all the ISO cost to the right. You can say outwork. Okay, that would be something like this. Now you can afford 9 units of labor and 9 units. Okay, the same slope because the relative right.
Let's see.
Okay, good. Yeah. Changing the relative price. Okay. So if the price of labor is higher than the price of the capital, the slope is very steep. And vice versa. So now let's combine what we learned with for the ISO1 and ISO-cost to come up with the cost minimization to variable of input. So now we can minimize, we can select an optimal choice for a firm to minimize their costs. Okay, so one of the steps to reach the target, the objective of a firm. If they want to maximize their profit, first they have to think about how to minimize their costs. Okay. They try to maximize the difference between total revenue and total cost. So the first step, try to minimize total cost. Okay, so again, just step by step. Okay, so let's say this firm pay this ISO cost line because their total cost I think they can afford is still 6. The price of labor and capital is still $1 per unit. So now it is the ISO cost. If I put, remember what we learned with consumer optimal
Choice.
decision. Now we put an ISO here.
Yes.
Right?
Idea.
So, and the tendency between the ISO and the ISO cost. The tendency, we reach the optimal choice for the firm to minimize the cost. The firm can produce a specific level of output they want. Okay, with the lowest total cost, they can minimize the total cost and still achieve holding the level of output they want. That's kind of a tendency. Only at the tangency between the isoquant and isoquants. Okay, and can somebody help me with, and remember that at the tangency, the slope of isoquant and isoquant is the same. Slope is the same here, right? This angle. Okay, so can somebody help me with the slope of the isoquant? What is the slope of the isoquant that we just demonstrate? What is the slope? The slope of isoquant and isocos. At the tangency. So what is the slope of the isoquant? What is the slope of the isocos?
Minus marginal product of L on minus marginal of K.
The slope of isoquant and isocot are all equal to delta K over delta L, right? Label here, capital here. And the slope of the isocos equal to the relative right of labor L. Oh, capital.
Yes.
What is the isoquant of
Delta.
isoquant? No. What is the slope of the isoquant?
Delta.
It is the slope of the isocos, right? This blackboard is very annoying. Too small for me. It is the slope of isocos. Right? So, at the tangency, because the slope of isocon equal to the slope of isocons. So, the slope of isocon equal to the slope of the isocon. And the slope of isocon equal to MB MBL over MB marginal product. Okay, and this one MBL over MBK we call the marginal rate of technical substitution. Okay, so the data all of this is the slope of remember that at the tendency, the slope of isocos is angle is same. Okay. So now, from this one, you can have. So we can do negative side is are excluded, so we have M B L over B L equal to M B K over 3K. This is what we call the equi-marginal principle. Hopefully you still remember what is equi-marginal principle. So the equi-marginal principle, basically the marginal product per dollar that we spend on labor in capital is the same. Marginal product per dollar that we spend on two variable input here, labor and capital is the same. Okay, so the last dollar that you spend on labor or capital bring you the same maximum product. Okay. So if the MBL greater than MBK over BK, what should this firm do? If MBL greater than MBL over BL greater than MBK over BK, what should this firm do?
He should use more labor.
They should hire more workers. Okay. If the MBL over BL greater than MBK over BK, the marginal product of labor is higher than the marginal product of per dollar they spend on. So they should like allocate more budget for hiring more workers. Okay. So until we reach this equilibrium, and the firm must minimize their cost and maintain the highest possible output. That is. Okay. So at point C, so basically point C is the tangency between the isocos and the isoquant, and the optimal choice for to minimize the cost. What's wrong with point B and point D? What's wrong? What's wrong with point B and point D? Why point C is the best option for this one?
Because is tendency.
But B and point D, yeah, it's not the tendency. But what's wrong with it? What is the difference between point B, D, and C? Why C is the optimal choice, not B and D? What's wrong with B and D about? What's wrong? What's wrong with B and D? Why we only reach the optimal choice for C, but not B and D over the graph? Yeah, sorry. Yeah, sorry. So you first.
In B&D is in the same line and just different, like the unit K and unit L, but OIC in the curve.
So agree that B, C, D produce the same level of output, but what's wrong with B and D?
I think they need to spend more budgets than what's it, and for being so the number of marginal product divided by price. Labor divided the price of labor is greater than the marginal product of capital divided by capital. So this would be like the flow would be spend more to increase the labor. And this will come to the person. So this is ultimate.
Yeah, that's good. So first, agree with Bảo that B, C, D, so basically we have the same level of output of 50. But what's wrong with point B and point D? Because point B, point D, so basically it's cross the higher isopos. So B and D require like higher, so they need to basically use more like unit of labor and capital. It's little, it's incur a total cost of 7. So out of the budget. Point B and point D, while point C we have the same level of quantitative output of 50, but we have a lower total cost. Okay, the lowest total cost to maintain the same level of quantity of output of it. So voices in tendencies. Okay, and here also imply another property. That's good. So basically, at point B and by D, we don't reach this equimarginal principle. Okay. Otherwise, if you use another isocon here, only as the tendency between a higher isocon with this isocon we reach the equimarginal. Would be around here. Okay. That's good. So basically, point B and point D is not the optimal choice for the firm. Yeah. Because only at the voices. So basically that the cost minimizing, or you can think that the typical, the latest cost to producing an output of 50. Okay. So basically, assuming that, another question, assuming that this firm has a total budget of $6, what's wrong with, let's say, a boy on this actual cost? What's wrong with any boy here? Name. What's wrong with any boy here?
They are the
So assume that we have a budget of 6.
Okay.
What's wrong with a boy here?
Thereby, they cannot produce enough the products, so they born inefficiency.
Yeah. This one, they cannot produce the expected quantity of output because they don't use all of their resources. They don't spend all of their income. It's not efficient. Okay. So only at the tendency between the isoquant and isoquant. Firm can maintain the quantity of output that they want and minimize the loss. Now, so we done with the foundation to establish a cost curve. So now, if assuming that something change, right? So we have a like different level of budget, and we have different tendency. Okay, assuming that like next year this firm then keep the profit and reinvest in their business, or something happen, the government give them more money, something like that. So basically they have a higher, let's say they have a higher budget, they can afford like more input. So we can find out the tendency with the consequent, and we have a new optimal choice. And then next year something like the business go very well, the firm have more and more money and they can afford like more money, something like that, more money, something like that. So you can save, you can boost all the asset cost outwork and you can reach a new tendency. Okay, so mathematical you find different tendency between isoquant and isoquant, and that correspond to point A, point B, and point C. So a cost curve represents the relationship between the cost and the output, unit of output. Okay. So see our initial optimal choice. Then, assuming that next year you can have more budget, you can save as cost our work, and we will identify another higher isoquant. We can produce a more quantity of output. This one. This year you only can produce like 50, you equal to 50 here. Next year, because you have a higher income, you have a high investment, high income from this year, and you can reinvest that kind of money or your business. Next year you can have more input and you can create more, produce more quantity of output, let's say 100 here. Then when we harmonize all the tangency between the answer quant and the answer cost on a graph, and we have the cost here, and I would say this one is the total cost. Okay, this one now the output, the quantity of output. Represented by Q, and then point A correspond. A here could be here. That's correspond to 6 total cost, right? And it correspond to Q equal to 50. Okay, so next year you have a higher budget, you can afford more total cost, you can produce more. That's correspond to oil. That's it. That's what A here. And then now, how much unit of output that you can produce?
100.
100. And then when we one point B, we get more possibility, something we call it cost. Okay, so the cost curve represents the relationship between
The cost and the quantity.
total cost and
The quantity of
quantity of output.
numbers.
It is very important for the next lecture. Okay. Somebody can tell me why the straight line, what we call it a cost curve.
Because in the future, maybe what we call the first, maybe it won't go straight, maybe it go up or down.
That's a good hint for you. So please spend time review the lecture next week. So most of the cost curve that we learn next week is kind of like you say it's not straight line. That's why we call it a cost curve. Okay, it is just an illustration. So in reality, we have different kind of bending same curve. Okay, that's why we call it a cost curve.
I think it will affect by the variable cost.
Yeah.
So it change, we call variable cost change.
It's what it's just an illustration. Assuming that like let's say we have a higher, we can afford a higher something like that, but now the quantity of output is just increasing not much as and C would be around here, and then we have constant. Okay? Any question? I think that's good enough for the lecture this week. So because more of the concept of the insight that I want you to understand, most of you get it quite really better than last week. So that's enough for the lecture this week. And spend time preview the slide first. So I think like to make it more efficient, so you should spend time reading the slide first. Okay, so in class I just like summarize the main point. save our time. Okay, if I go through all the slides one by one, we don't have enough time. So now time for me to summarize what I want or something like that. Just talking about the slide. So you should read the slide first.